Okay, this is section 4.1, part 2, and we're going to talk about several things today, but the first thing we're going to talk about are coterminal angles. So we learned yesterday that coterminal angles are angles that share the initial and terminal side. So basically, they are angles that look the same, but are named in different ways. So for example, if I just had this angle right there, you wouldn't know, okay, is this a positive angle? Was this a negative angle? Did they go this way? These are coterminal angles. They look exactly the same, but they can be named in lots of different ways. Okay, so let's look at example 1. It says, sketch the following angles and find two coterminal angles, one positive and one negative. So basically what they want us to do is to name this angle two different ways. Okay, so first of all, we're going to sketch 380 degrees. All right, so just as a reminder, 0, 90, 180, 270, 360. Okay, so let me get a different color pen here. We want to sketch 380 degrees. So we know, here's my initial side. We're going to go one complete revolution, and then we are going to have 20 degrees left because one complete revolution is 360. So I know that I have 20 degrees left I need to go over. So I've sketched 380 degrees. So now I want to rename this angle. Well, we just said that this could be 380 degrees, or this angle right here, if I didn't have these my arrows pointing to it, it would just look like a 20-degree angle. So another coterminal angle, the positive one, is 20 degrees. Okay. Now let's name a negative angle. So if I have this angle right here that I'm showing, we know it's 20 degrees, but I need to name it as a negative angle. So I know I'm going to end up going from the initial side backwards. Okay, if I know this is 20 degrees left over and I go negative, doesn't it make sense that you would take that 20 and we're subtracting 360 from it? So you see it's 340 but in the negative direction. Okay, so 20 degrees, negative 340 degrees, and 380 degrees are all the same angle. Those are all coterminal angles. So you're going to see a shortcut pretty soon. The shortcut for finding coterminal angles, would be to subtract 360 to find a negative one and keep on subtracting until you can't subtract anymore. Or if you need a positive angle, to add 360. Okay, so let's do example or part B. So part B, let's sketch 220 degrees. So I'm not going to label them, but we know that's 0, 90, 180, 270. So I know that when I draw my initial side, here's my initial side. I'm going to go counterclockwise. There's 90, there's 180, somewhere around here for 220 because this is 270. All right, so there's my first angle. So now let's find another positive coterminal angle. If I want to find a positive coterminal angle, the shortcut is to take my initial angle and add 360. Okay, because I can just go around a complete revolution. That angle is going to look exactly the same. So 220 plus 360 is going to give me 580. So that's another way to name this angle. To find the negative angle, because here's the negative angle, the shortcut would be to subtract 360. Okay, so I know I needed to put the 360 up here, but we know it's going to be negative when I have my answer. Let's see here. Okay, so 360 minus 220. So that's going to give me a negative 140. Okay, so another coterminal angle. Another way to name this angle is 140. Okay, so remember the shortcut is to find another coterminal angle that's positive, add the 360, to find the negative angle, subtract the 360. All right, so let's sketch negative 330 degrees. So this time we're going backwards. All right, so if this is my initial side, well, here's my initial side. I know I'm going to go this way, so this is negative 90. Here's negative 180, negative 270, all the way around almost until I get to 360, but I'm going to stop right there. So how much am I going to have left? That's a positive 30 degrees, right? So another, 330, add that 360 is a positive 30-degree angle. Okay, now what if I want to name this as another negative angle? Well, if I have a negative 330 degrees, this time I'm going to add a negative 360 degrees, so 690 degrees. Okay, so that wasn't too bad because you guys are used to working in degrees. But what if we switch it and we have to do it in radians? Okay, so let's look at what it looks like using radians. All right, first of all, let's practice sketching. Okay, so when I'm in radians, remember this is 0, 90 degrees is pi over 2, 180 degrees is pi, 270 degrees is 3 pi over 2, and then 360 is 2 pi. All right, so if I want to sketch 13 pi over 6, one way to do this is to change this degree to degrees from your assignment from yesterday. That's going to be a lot of extra work. Here's how I look at it. 13 over 6. 13 over 6, isn't that the same as 2 and a sixth? Okay, that means I'm going to go around 2 complete revolutions and then a sixth of the way up. Okay, so I'm going to go ahead and draw that. And you can think of it as a sixth of the way to pi because it's 13 pi over 6. So I'm going to start with my initial position. I'm going to go around 2 complete revolutions. There's 1, there's 2, and then a sixth of the way, 1/6 of pi. So a sixth of the way to pi, this is pi over 2, a sixth would be somewhere in this first quadrant. Okay, so there's my angle. So now let's name another positive angle. Okay, I don't know why that keeps coming up. There's 2 ways we can do it. Remember, we've been subtracting and adding 360. Well, remember, 360 degrees in radians is 2 pi. Okay, so if we want another positive angle, let's just add 2 pi to that. So 13 pi over 6 plus 2 pi. Now here's where you guys are going to have to do a little bit of work. These are fractions, so that 2 pi is over 1, so you have to find a common denominator. So my common denominator is 6, so if my common denominator is 6, that 13 pi is going to stay the same. But this fraction is going to change, so if I have to change my bottom number to a 6, I'm going to multiply the top number by 6, and that's going to give me 12 pi. So my answer is 25 pi over 6. That's another positive coterminal angle. Okay, now let's find the negative angle. To find the negative angle, we're going to subtract 2 pi. So I'm going to do that over here. So I have 13 pi over 6 minus 2 pi. And we already know that 2 pi is 12 pi over 6, so I'm going to go ahead and change that to 12 pi over 6. All right, so when I do that, when I subtract straight across 13 pi minus 12 pi, I get pi over 6. But the problem is I'm supposed to have a negative answer. All right, so when you need a negative answer and you end up with a positive, you just need to do it again. Subtract 2 pi again. So I'm going to subtract, 12 pi over 6 again. So I have 1 pi over 6 minus 12 pi over 6, negative 11 pi over 6. Okay? So let's do part B, 3/4 pi. So if I want to sketch this, I know I'm going to go 3/4 of the way to pi. Remember, 0, pi over 2, pi. So here's my initial side. 3/4, I'm going to be somewhere over here in quadrant 2. Because 0, pi over 2, pi. 0, pi over 2, pi. All right, so now let's find another positive coterminal angle. So I have 3 pi over 4 plus 2 pi. So I need to find a common denominator. That's 3 pi over 4. My common denominator is 4. So I need to multiply that by 4. So that's going to turn to 8 pi. And I get 11 pi over 4. It's another way, if I graphed 11 pi over 4, it would look exactly like that. All right, so now let's find the negative angle that goes with that. So I'm going to take 3 pi over 4 and subtract my 2 pi. So subtract 2 pi, but I know 2 pi is 8 pi over 4 when I find that common denominator. And I get negative 5 pi over 4. Oh, not negative. Yeah, negative 5 pi over 4. Okay. All right, part C. I want to sketch negative 2 pi over 3. So we know we're going to be going clockwise. Remember, if this is 0, this is negative pi over 2, and this would be negative pi. And do you see I want to go negative 2/3 of the way to pi? So can you see which quadrant you're going to be in? We're going to be in this third quadrant. All right, so negative 2 pi over 3, let's add, or let's find our positive coterminal angle. So I'm going to add 2 pi to that. When I find a common denominator, that's going to give me negative 2 pi over 3 plus, my common denominator is 3, so 3 times 2, that's 6 pi. And that's going to give me 4 pi over 3. Okay, let's find another negative way to name this angle. So I'm going to have negative 2 pi over 3 minus my 2 pi, so minus 6 pi over 3. And I have negative 8 pi over 3. Okay. All right, so now you know how to find coterminal angles in degrees and radians. Next thing we're going to talk about are complementary and supplementary angles. You learned this back in geometry. Remember, two positive angles are complementary if their sum is 90 degrees or pi over 2, because pi over 2 is the same as 90. And two positive angles are supplementary if their sum is pi or 180 degrees. So find the complement and supplement of the following. Let's find the complement first. To find the complement, you're always going to do 90 degrees minus the angle that they give us. So that's pretty easy, 45 degrees. To find the supplement, we're going to take 180 degrees. So that's going to give us 135. We like these. We like degrees because you're used to doing those. The complement for 120, since it's over 90 degrees, it's not going to have one. There's no complement. We do have a supplement. 180 minus 120, 60 degrees. Okay, those are easy. You did those back in geometry. Okay, let's change it though, and let's look at it when it's in radians. Okay, so radians, to find the complement, remember to find the complement, it's 90 minus the angle that they give us, but instead of using 90, we put pi over 2 in its place. So pi over 2 minus 2 pi over 5. So the only problem with this, we just have to find a common denominator. The common denominator between 2 and 5 is 10. And remember, if your bottom number changes, your top number has to change. So 2 times 5 will give me 10, so that's what I multiply the top by. That's 5 pi over 10. 5 times 2 will give me 10, so that's what I multiply the top by. That's going to give me 4. So 5 pi minus 4 pi is just 1 pi over 10. That's the complement. The supplement is 180 minus the angle they give us, but 180 is pi minus 2 pi over 5. So find a common denominator. My common denominator is 5. So this is going to change to 5 pi over 5 minus 2 pi over 5, and I get 3 pi over 5 as the supplement. Okay, 4 pi over 5. 4 pi over 5, and if you think about it, do you know where 4 pi over 5 is? It's 4/5 of the way to pi, somewhere over there. Is that going to be bigger than 90 degrees? Yeah, I can already tell. It's bigger than 90 degrees, that angle is, so is it going to have a complement? No. So complement, none. The supplement is going to be pi minus 4 pi over 5. Find your common denominator, which is 5. So I have 5 pi over 5 minus 4 pi over 5, pi over 5. Okay. The last thing we're going to do is probably the easiest part of your assignment. Sometimes angles, when we measure them in degrees and radians, and sometimes when they're measured in degrees, they break it down even further. It can be measured in degrees, minutes, seconds. And I always think of degrees, minutes, seconds, just like you would as in time. Instead of hours, minutes, seconds, it's degrees, minutes, seconds. But they break it down the same way. 1 minute, and this is an apostrophe is the symbol for minute, is 1/60th of a degree, just like a minute is 1/60th of an hour. And 1 second, and its symbol is quotation marks, is 1/60th of a minute. Okay? So here's what they're going to do. They want us to convert the angle measure to decimal degree form. That means instead of reading 64 degrees 45 minutes, they want to know what it would be as a decimal. Okay? So when you are changing this to a decimal, here's what you're going to do, and you'll need a calculator for this, but I want to see the work written out. It's going to be 64 degrees plus, if 45 minutes, and each minute is a 60th of a degree, I'm going to divide this by 60. So it's going to be 64 plus 45 divided by 60, and then when you put that in your calculator, you're going to get 64.75 degrees. Okay, so let's look at this one. I have a negative degree, which you're going to do it the same way, but you're just going to put the negative sign out in front. But this time I have degrees, minutes, and seconds. So I have 408 degrees plus 16 minutes, and I know that's a 60th, 16/60th of a degree, plus 25. Now on this one, I'm not going to divide it by 60 because these are seconds, and we want to know what part of a degree is that, okay? Well, if it's 60 minutes in a degree, 1/60th is a minute, so 1 minute is 1/60th of a degree, and 1 second is 1/60th of a minute. You're going to divide this not by 60, but 60 times 60, which is 3,600. Okay, so minutes are divided by 60, seconds are divided by 3,600. And when you put that in your calculator, you're going to get negative 408.273. We'll go 3 decimal places. Okay, and then the last part, they're going to have you go the other way. They're going to give you the decimal degrees, and they want us to change it to degrees, minutes, seconds. And a lot of time you'll just see this shortcut. DMS stands for degrees, minutes, seconds. All right, so to do this, I know I have 280 degrees, And I'm going to take the decimal part, which is 0.6, and if I divide it by 60 to get that answer, I'm going to multiply by 60. So when I multiply zero point 0.6 times 60, I get 36 as my answer. That is your minutes part. So 280 degrees, 36 minutes. Okay, on this one, that should have a degree mark, negative 0.355 degrees. So first of all, I know I have 0 degrees because I don't have a whole number. I had 280 something here, okay? So I need to take, and I have negative, I need to take this decimal part and multiply it by 60. And when you multiply that by 60, let me see what you get. 0.355 times 60. I get 21.3. Okay? When you get a decimal like this first whole number is your minutes part. This 0.3 is going to turn into your seconds, but I need to take that 0.3 and multiply it again by 60. Okay, now why did we not multiply this by 3600? Because that's what we're actually doing. We're taking the decimal part, we multiply it by 60. We took this decimal part, multiply it by 60, got this. We take the decimal part again, multiply it by 60 again. And when we get that, we get 18. So it's going to be 0 degrees, 21 minutes, 18 seconds. Okay, so multiply by 60. On this, we didn't have any decimal part, so I knew that was my answer. If you multiply 16, you have a decimal part again. You're going to use the whole number for your minutes. Take that decimal part, multiply by 60, and that's going to be your seconds. Okay, you're going to have a worksheet that you're going to do over section 4.1, part 2.